Okay, so we will do this May-June paper. Okay, so let's actually look at this paper. Okay, so if you look at the first question over here, okay, so they mentioned that gallium, okay, is an element, okay, in group 13. And a sample of gallium is analyzed using mass spectrometer. Okay, the mass spectrum is given. Now, whenever you look at this mass spectrum, please remember, okay, you need to make sure that, okay, whatever the abundance that you have, okay, you need to add them first. Okay, in this case, I've added and I found out that they are 100%. This is very important. Yeah, so you need to do that first. Now, explain what is meant by the term relative atomic mass. Okay, so relative atomic mass I've written over there. Okay, is the mass of 1 mole of atom, okay, in relative to 1/12 of the mass of 1 mole of carbon-12. Yeah, so please remember how to define this. Okay, so it is going to be defined in this way. So make sure you are able to define this properly. Now the next question is
a lot, yeah, so I'll get this headset. So okay, now you see when we calculate, okay, this one I already calculated for you. Okay, so when you look at over here, when you calculate, you will get this 62.80. That is going to be our relative atomic mass. Okay, so this one you need to know how to calculate, very important. Yeah, now the next question is, okay, they say that they want you to complete this table describing a gaseous atom of gallium. Okay, let me check. Okay, so okay, good. Okay, thank you, Christopher, Arwen, Megan, and Michael. Yes, so I think Michael and Megan, 69.8. 69.8 or 62.8. Can you guys check again? The marking key, when I check, 69.8. So I'm wrong. Yeah, 69.8. Okay, thanks. Okay, 69.80. Okay, so that's going to be the answer for the first one. Yeah, correct. Okay, Ryan, correct. So now the second part, the C, yeah, complete the table which describes a gaseous atom of gallium. So you see here the isotope is 71 gallium, so nuclear number, okay, is going to be the 71 directly, so you just need to put 71. Total number of electrons in the lowest energy level, do remember, okay, every single time you fill in the lowest energy level first, so it means you fill in 1s2, then followed by the rest. So the lowest energy level, the total number of electrons must be 2. No need to think a lot, it's 2. And the type of orbital which contains the highest energy level, in order to do that, you need the periodic table. Okay, and if you look at the gallium part over here, okay, if I make it bigger, okay, you can see gallium. Okay, gallium is going to be somewhere here. Okay, and we need to know that, okay, when you look at the data booklet or the periodic table, okay, this part, okay, is going to be known as S block. Okay, S block, and then this is going to be your D block. Okay, D block, and this is going to be your P block. So you can see gallium is in the P block. Yeah, so because of that, okay, so I think the mic is too loud. So if too loud, how about the others? If it is okay, reduce the sound. Yeah. How about now, Christopher? Okay. Okay. Now, so if you look at this, okay, you can see it's going to be at P. Okay, so the one that, okay, when you look over here towards the end, okay, P block tells us that the last electron, okay, is going to be at P orbital. Okay, so because of that, okay, the answer over here, okay, if I make it smaller again, okay, type of orbital which contains the electron in the highest energy level, so this is going to be P orbital. Okay, so that is going to be how you answer this. Yep. So the next question, okay, is going to be when gallium is heated in excess chlorine, okay, gallium trichloride is made. Okay, draw the shape of gallium trichloride. Okay, if you look at gallium, gallium is going to be group 13. Yeah, so gallium is group 13. Okay, because of that, the valence electron is going to be 3. So you know that gallium is similar like aluminium, 3 valence electron, and then you have Cl, okay, 7 valence electron. So they are going to actually form a trigonal planar. Yeah, so draw the shape. Okay, so they just want you to draw the shape, no need to draw the valence electron and so on. Just I think like this is enough already. Okay, you draw the shape like this, okay, and suggest the bond, okay, between Cl, gallium, and Cl. So they want you to find out what is this bond. So this is going to be 120 degrees, okay, which is going to be a trigonal planar. Okay, so just to refresh your memory on this, okay, so do remember tetrahedral, okay, tetrahedral 109.5 degrees. Okay, so now this is trigonal planar, okay, 120. Tetrahedral, okay, there are some variations, okay, which is like something like ammonia. Okay, 1 lone pair, 3 bonding pair. So if you have 1 lone pair, 3 bonding pair, okay, the bond angle will be smaller a bit, so 107 degrees. Okay, and what type of shape? This is pyramidal. And then if you look at water, okay, 2, okay, lone pair, okay, because of that, this is bent. Okay, and then the bond angle is 104.5 degrees. Okay, so you can actually get this. Okay, there are more, okay, but I don't want to cover it now. Okay, so just to refresh your memory on this. Yeah, so now, okay, if you move on, okay, gallium oxide, okay, and aluminium oxide, they react in the same way with ACl and NaOH. If you look at aluminium oxide is a amphoteric oxide. Yeah, so can someone help me to define what is amphoteric? Michelle V, can you tell us what is amphoteric?
I forgot, sir.
Okay, so maybe we'll ask Nathan. Nathan, what is amphoteric oxide?
Amphoteric oxide, sir?
Yeah, amphoteric oxide.
Amphoteric oxides are basically oxides that behave like both basic and acidic.
Yes.
Oxides.
So basically the oxide that can react with both acid and base. So it means Al2O3, they can react with acid, they can react with the base. So therefore, group 3 oxides there are amphoteric. So if you look at gallium, okay, gallium is going to be, if you look at the periodic table, gallium is directly below aluminium. It means that, okay, they are also going to be amphoteric oxide. So in your textbook, in your syllabus, we only learn about the equation related to aluminium oxide, which I have written over here, but I can rewrite this again for you. Yeah, please remember this. So Al, okay, aluminium oxide, they can react with ACl. Aluminium oxide can also react with NaOH. Okay, but special is going to be NaOH must have water to balance the equation. Yeah. So here, okay, when I write this, they are going to form AlCl3. Okay, and then okay, AlCl3, and then there is water. Okay, and what will happen here? They will form a salt which is Na, okay, Al bracket OH4. Okay, so now let's actually try to balance them. Okay, so balancing is going to be, okay, if I have 2 over here, so of course I need to put 2 here. Cl, there are 6, so I need to put 6 over here. Okay, hydrogen, there's 6 over here, so I need to put 3 here, and now everything is balanced. Okay, and if you look at the reaction of aluminium oxide with sodium hydroxide, okay, you see Al2, so of course I need to put 2 there to make Al2, and then you see because I put 2 there, sodium become 2, and then now if I try to balance the maybe oxygen or hydrogen, you see that they have 4 and 2, so 8 hydrogen. Okay, if 8 hydrogen, 2 hydrogen here, so I need 6 hydrogen, so I put 3. Okay, now 6 hydrogen. Now I just need to check whether oxygen is balanced or not. 3 oxygen, okay, 2 oxygen, and 3 oxygen. When I add, okay, now I have 8 oxygen. Now here is also 4 times 2, 8 oxygen. So it's balanced. Okay, so what is important over here is, okay, you learn how to balance first. Okay, once it's balanced, okay, now you can apply, okay, the same thing to related to gallium oxide. So now they say suggest the equation for the reaction between gallium oxide and ACl. So just need to change, okay? So just need to change this, okay? Change the Al into gallium, that's it. So Ga2O3 plus 6 ACl. It's going to give me 2GaCl3 plus 3H2O. So in order to do this, okay, you need to know what is the reaction, yeah, between aluminium oxide. Suggest an equation for the reaction of gallium oxide and sodium hydroxide. So you see, just the same, replace this with Ga. So GaO3, okay, plus 2 NaOH plus 3H2O gives you 2 GaAlOH4. Okay, if you look at the marking key, okay, there is another reaction, okay, which is not written in the textbook, but it is also given in the syllabus. Okay, so there is another reaction where they say that instead of giving you this NaAlOH4, you can also have NaAlO2. Okay, and you can have water. Okay, that is another example. Okay, so in this case, okay, aluminium oxide, okay, plus NaOH, okay, gives you this. Okay, so no need to put water here. So there is another equation involved over there. So if you give answer, okay, as the GaAlO2 plus water and you balance it, is still also correct. Okay, but I will suggest to follow the one in the textbook, the one that we have learned. Okay, this is going to be the one that we have learned. So you just put over there, enough. Yeah. Now, the next question. Okay, so just to check. Okay, Benedict, everything okay?
Yeah.
Okay, let's move on. Yeah, nitric acid can be made in a 3-stage process. Yeah, so ammonia is oxidized by oxygen, okay, from air to form nitrogen monoxide and water. So they have already given you the what is going to be produced. So you just need to write the equation. So ammonia, okay, oxidized by air, so plus O2, okay, to form NO and water. So if you try to balance this up, okay, so you can see if I want to balance this, okay, nitrogen oxide, yeah, hydrogen. So if I have H3, quite difficult to balance, so normally I put 2. Okay, when I balance, I put 2, and then I have 2 nitrogen, automatically I put 2 there. Okay, now I will have 6 hydrogen. So when I have 6 hydrogen, I just need to put 3 there. Okay, so towards the end only I balance the oxygen, which is 3 oxygen, 2 oxygen. So 5 oxygen. How do I get 5 oxygen? 5 over 2. Okay, so if I don't want to write in fraction, I need to times everything by 2. So if I times everything by 2, is 4 NH3, okay, plus 5 O2, okay, 2 times 2 is 4 NO, okay, 2 times 3 is 6 H2O. So this is going to be the answer that they want. Yeah. Now, draw a dot and cross diagram, okay, to show the arrangement, okay, of outer electrons in a molecule of ammonia. Now, ammonia, okay, is going to be group 15. Okay, they have 5 valence electrons. Okay, 5 valence electrons. So if you want to draw the cross dot diagram, okay, so you just need to put the nitrogen, like what I've done over here. This is the when I plant, so I just put the nitrogen. Okay, 5 Okay, and I know that, okay, there will be 3 bonding pair. Okay, I just put like this, the hydrogen, hydrogen, and hydrogen. Okay, I just put X, I put X, I put X. Okay, I know in IGCSE, we tend to do the circle, yeah. So if you want to put the circle also can, if you don't want to put the circle also can, yeah. In the marking key, they don't put the circle for A levels, yeah. But it's okay if you want to actually follow like similar to IGCSE, you want to put the circle over here, okay, you want to put the nitrogen, then you want to actually show everything like this also can, yeah, no problem. Okay, you put like this, okay, and then X, 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 hydrogen, hydrogen, hydrogen. It's also fine. Yeah, it's okay. Okay, so as long you show the outermost electron is enough already. Yeah, the next question. Okay, in the boxes, okay, give the oxidation number of nitrogen in the nitrogen containing species. Yeah, so here, okay, do remember oxygen is always -2. Yeah, so if you want to find what is N, so just put X, okay, plus 2 times -2. This is a neutral molecule, so equals to 0. Yeah, so then you will have X equals to +4. Yeah, please remember, we don't simply put 4, you must put +4. Must, yeah, must put +4. So here the same method. Okay, if you want to calculate all together also can. Hydrogen ion is +1, or you just want to calculate the ion itself also can. Let's say I try the ion itself, NO3 minus. Yeah, so if this one is X, okay, so plus 3 times -2 equals to -1. X equals to -1, you bring over there plus 6, so it's going to be plus 5. So don't write 5, you write down plus 5. Okay, very important. And the last one, okay, this is X, so plus -2 equals to 0, X equals to 2, you write down plus 2. Don't go and write down 2, yeah, don't do that. Okay, don't do that. Okay, make sure you use the positive sign over there. Now, explain why the reaction in stage 3, okay, is described as a disproportionation reaction. So you see, yeah, if you just simply look at disproportionation reaction, the nitrogen itself, okay, can be oxidized. At the same time, they can be reduced. Yeah, this one is by looking at the oxidation number. Yeah, but here they want you to use transfer of electrons, so something extra. You don't use the oxidation number over here. Okay, please don't do that. Yeah, so here, okay, to make it easier, okay, if you look at Fe, one example, Fe2 plus to become Fe3 plus. How Fe2 plus can become 3 plus? You remove another 1 electron. You remove electron, so we don't write minus electron, so normally we write, you bring over there plus electron. So it means that if you have increase in oxidation number, okay, from +2 to become +3, it means that they are losing electron. Okay, they are losing electron. So using the same concept, what we can say over here, okay, so let's actually see here. Okay, so maybe Giuliano can help over here. +4 to become +5 over here, Giuliano. Is it losing electron or is it gaining electron?
Losing.
Okay, so it's losing electron. Okay, very important, correct. Okay, and then Donna, +4 to become 2. Is it going to be losing or gaining, Donna?
Gaining.
Okay, this is gain. So when you answer, okay, please answer, okay, that from NO2, okay, to become HNO3, and then NO2 to become NO. So you need to mention that, okay, this one, NO2 to become HNO3, it is going to be losing electron. And this is going to be gaining electron. So as long you mention that, and you need to also mention why it's called disproportionation reaction. Okay, disproportionation reaction is, okay, where NO2 over here can gain and lose electron it means they can undergo gaining and losing electron at the same time, yeah, which is going to be a disproportionation reaction. You need to stress on that, yeah, so you will get the 2 marks over there, yeah, very important. Okay, the next part. Now, the release of nitrogen monoxide, okay, into the atmosphere causes atmospheric pollution. State and explain the effect of nitrogen monoxide gas in contact with moist air. Okay, so if in contact with air, okay, moist air, it means they contain H2O, yeah, so they can actually give you acid rain, yeah, it will give you HNO3, yeah, they will give you acid rain. Okay, so state and explain the effect. So write down they will form, okay, or you can say they will react with water, okay, react with water to form acid rain. Okay, so the effect, okay, so if you want to enter, maybe this acid rain will destroy the building and so on, you can write down. Okay, but okay, apart from acid rain, okay, they can also react with water and oxygen, okay, to give you photochemical smoke, or they can actually destroy the ozone layer. This is also included in your marking key, but because most of the time when we discuss in our textbook, yeah, we always discuss based on acid rain, yeah, so it's better also to write down in form of acid rain, yeah, so you write down react with water to form acid rain, and this acid rain can destroy the buildings and so on, okay, you can actually write down. Okay, now the nitric acid made in stage 3 can be reacted with ammonia to form ammonium nitrate. Okay, so here, okay, they have given you 2 equations, and they want you to calculate the volume of nitrogen dioxide. They want this volume, yeah, measured at room temperature and pressure, required to make 40 tons of ammonium nitrate. So it means that the end product they give you, this is 40 tons, yeah. So in chemistry, we don't deal with tons, we always deal with gram, because it must be number of moles, it must be in gram. So change that 40,000 into gram, so you can see 40 tons, okay, is 40,000 kilogram. So I want to change it into grams. I put 10 to the power of 3. Yeah. So kilo is 10 to the power of 3. So in the end, okay, I will change it into gram. So I just put this one is going to be in gram. So the next thing is, okay, I need to find the number of moles. Just need to find the number of moles of this. So nitrogen is 14. Okay. 4 times 1, 14. 3 times 16. Okay. If you do that, okay, you can calculate and you will find out that this is going to be 5 times 10 to the power of 5 moles. Yeah, so it means that, okay, I want to relate to this equation. Okay, how do I relate to the previous equation? Okay, basically to find the number of moles of HNO3. So we know that 1 mole is going to be 1 mole. Yeah, so it's going to be 5 times 10 to the power of 5. Now, when I relate to the previous one, do remember all of this is coming from here. Don't go and times by 2. This is very important. This is a different equation. Yeah. So don't say this one to here, this is going to be 10 times 10 to the power of 5. No. Yeah. So this one directly, they are exactly the same, which is going to be 5 times 10 to the power of 5. This is very important. Don't go and times by 2. Yeah. Now, once you have that, okay, I need to calculate what is this. So now you use the ratio, the 2. Okay. 2 is representing 5 times 10 to the power of 5. Okay. So what I can do, I just say, okay, 1 is 2.5 times 10 to the power of 5. Okay. So 3. 3 is going to be this one times by 3. Yeah. So eventually you can calculate, you will get this as 7.5 times 10 to the power of 5. For even, can you understand this? Even, are you there?
Yes, sir.
Okay. Can, yeah. Now, so if you continue, okay, so you found out, okay, this is going to be the number of moles, okay. So we know that 1 mole, okay, is going to give you 24 dm cube, okay. So if you have 7.5 times 10 to the power of 5, okay, so you just need to times by 24, you will get, okay, after I times, okay, I already work out earlier, okay, so after you times, you will get this 180 times 10 to the power of 5, and then I simplified that to become 1.8 times 10 to the power of 7, but do remember it is still in dm cube. So volume, okay, they didn't give you any unit, so I'm just going to write down 1.8 times 10 to the power of 7 dm cube. Okay, that is going to be my answer. Yeah. And then the next question, state one use of ammonium nitrate. This one, no need to think. I think every year they will ask you this kind of question. Ammonium nitrate is fertilizer. Okay, fertilizer. Okay, if you notice why not Z, yeah, so this, we always follow the British English, yeah. So now fertilizer, yeah. Now if you move on to question number 3, yeah, sucrose, okay, reacts with water. You see sucrose, this is sucrose, and then they react with water to form glucose and fructose, something like the bio, yeah. But now, okay, if you use the concept, let's actually find out what is the molecular formula, because later it will be helpful also for us. So you see 1, 2, 3, 4, 5, 6, okay, C6, okay. So how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many oxygen? If you count, yeah, okay, 1, 2, 3, 4, 5, 6, okay. And if you do the same thing, okay, this one also you will get C6H12O6. Okay, so now, okay, when they say suggest a name for this type of reaction, you see from carbon 12, suddenly they are breaking into 2 simpler molecules. Yeah, if this one, okay, with breaking using water, yeah, suggest a name. Okay, this is going to be what we call hydrolysis. Okay, breaking using water. Yeah, so this is going to be example, okay, of hydrolysis. Now, explain in detail why glucose and fructose are pair of structural isomer. It must be referred specifically to these 2 molecules. Okay, what is structural isomer? Yeah, so structural isomer, okay, if you look at it, okay, before we answer, you need to know what is structural isomer. Yeah, we under structural isomer, okay, we have 3 main types. Okay, structural, okay, they have number 1, position, okay, positional. Number 2, they have what we call functional group, and then number 3 is going to be chain, yeah, or branch, yeah. So you can see any of these will come under structural isomerism. And if you look over here, okay, the important thing about structural isomerism, they must have the same molecular formula, okay, different structure. So if you look at the structure, you see different arrangement, okay, of the OH. You see sometimes the OH is here, okay, sometimes I think, so far I think it's all okay, same, okay, even this one also doesn't matter, same. But if you look at here, okay, the position, okay, this one, okay, and this one is different, and then the position of this also different. So you can see that the position of the carbonyl group, okay, the double bond O is different, and then the position of the OH group, okay, and the OH group here is different. Yeah, so that is the detail. I don't know, I won't actually explain over here. So you just need to tell they have the same molecular formula, okay, molecular formula. And then you mentioned about the position, okay, the position of the carbon double bond O. And if you look over there, if you want to be more specific, it's a functional group isomer. Why? Because if you put over here, this is going to be aldehyde. Okay, there is 1 H. This is aldehyde. But this one looks like some, this is, if you count this as R, this is ketone already. So aldehyde and ketone, they are going to be kind of, even though they are carbonyl compounds, okay, they are different functional group. Okay, so it means if you want to take it in that way, but overall they still come into the same structural isomerism. Yeah, so you can mention about that different position of OH. The next question over here, okay, reaction A occurs faster in the presence of enzyme. Okay, so they say A, okay, this particular hydrolysis will be faster if you put enzyme, and with the enzyme, that is called reaction B. Yeah, the activation energy with the enzyme is 29. So they say predict the value of activation energy for reaction A without enzyme. So of course greater than 29. So you can, I just randomly put 50 plus 50 kilojoule. Okay, as long as, okay, whatever you predict is greater than 29. Yeah. Now the enthalpy change for the reaction is negative 14. Okay, so if you put the enzyme or catalyst, okay, maybe I'll ask someone, Owen, do you think the delta H will change if you use different activation energy, or if you put catalyst?
Yes, will change.
Yeah.
Yeah, will change.
Okay, they will not change. Yeah, they will not change. Okay, do remember. Okay, if I use the catalyst, okay, maybe they just go like this only, but they will not change this part. Okay, so to be exact, we just show like this going down only. Yeah, so the no change. Okay, so it's going to be, the value is going to be still the same, negative 14. Okay, no change. And they didn't ask you to explain, no need to even explain. Yeah. Now the next one, sketch a label energy diagram for reaction B. Okay, so use the relevant value. So they already give you the values. 29 is the activation energy. So if I want to draw, it's something like this. Okay, so you just need to tell that this one is going to be the activation energy, EA plus 29. And from here to here, okay, it's going to be negative 14. Delta H is negative 14. And what else? I think no need to mention anything else. Okay, or you want to put reactant product. It's okay, done. Yeah, these are enough, okay, to get the 2 marks. Okay, now 1 gram of sucrose, okay, is completely combusted. Yeah, the heat energy produced is used to increase the temperature of 250 gram of water inside the calorimeter. I hope you remember this kind of question. Yeah, so you are burning something, and then the heat is going to be released, and that heat is going to be absorbed or being measured by water. So when it is absorbed by water, okay, when you measure the temperature of water, it means the heat capacity, the C, must be coming from water. Okay, so we are not bothered so much about this 1 gram. Okay, so it means the mass that I use, okay, must be the mass of water. I think a lot of students will get confused with this, but last time I already mentioned to you, okay, which mass that we should use. Don't go and use 250 plus 1 gram, 251. No, we only going to use 250 gram. Yeah, so here, okay, explain, okay, what is meant by the term enthalpy change of combustion of sucrose. Okay, enthalpy change is the enthalpy change when 1 mole, okay, 1 mole, okay, of sucrose, okay, 1 mole of sucrose is completely burnt, okay, or reacted with excess amount of oxygen. They didn't say standard, okay, but if you want to include also can, okay, under standard condition. But if you don't want, also doesn't matter, okay, under standard condition. Now use the data booklet to calculate the enthalpy change. Okay, so here the data, you see the heat energy all transferred to water. The one that you they want you to use the data is just to find the C, yeah, which is 4.18. Yeah, the C is going to be in joule. Okay, joule something. So basically we will use the Q equals to MC delta T. Okay, the mass that I will use, okay, do remember, okay, not like, unlike physics, we do not need to change this into kilogram. Okay, if you are using 4.18, okay, because of the unit, I think something to do with gram, yeah, 4.18, so it means the mass is also gram, yeah, for chemistry. So straight away use 250 gram, 250 gram. The C is 4.18. Temperature change, you see, you don't need to worry whether positive or negative, because again, we know combustion is going to be negative. Okay, later you can think about it. Okay, do I need to change into Kelvin? Whenever change in temperature, no need, it doesn't matter. Okay, just need to find the difference only, 40.7 and 25. Okay, so that's going to be 15.7. Okay, so 15.7. Okay, do remember, don't go and actually 15.7 plus 273. Don't do that. Yeah, so just minus only. Yeah, once you do that, okay, can someone help me to find, okay, what is going to be the Q over there? And do remember, this Q is for 1 gram. If I want to find the enthalpy change of combustion, I need to go and change it for 1 mole. So 1 gram. Okay, while you guys are calculating, I will still write 1 gram, okay, of sucrose. Okay, 1 gram of sucrose, C12H22O11. So how many moles is this? 1 divided by 12 times 12 plus 22 plus 11 times 16. Okay, can someone help me to calculate how many moles is this? Okay. Michael have written, okay, Q, okay, thanks, Michael and Evan, yeah. Okay, so I write down first, the Q is 16406.5, yeah, that is your Q, Joe. Okay, now you need to change this, okay, for 1 mole, yeah. So if you calculate, okay, find out what is the number of moles of this, okay, and then, okay, you need to take this 16406.5, okay, is going to be for this number of moles. I want 1 mole means you need to divide by this value. Yeah, you need to divide with that value. Okay, and you will get a enthalpy change. Okay, that enthalpy change, I think Christopher has calculated, okay, which is 5611 kilojoule, and it must be negative, I think. Yeah. So you guys also calculate for me see whether it's correct or not. Okay. Then let me also see the marking key quickly. Yeah, correct. Okay, 5611. Okay, but do remember, okay, don't forget, okay, to put negative because this is combustion. Yeah, so negative 5611. Okay, so you need to find how many moles, then divide, okay, and you will get mole per mole. Yeah. So do remember, okay, if you calculate, of course, you will get negative 561100 joule something, yeah. Then you need to convert, okay, you need to convert to kilojoule. I'll move on. Okay, just to check everyone with me. So just so maybe I'll call someone. Okay, Chai, Nicholas Chai, is it okay, everything?
Yes, sir.
All right, yeah, let's move on. So here, okay, I'll try to go faster a bit, yeah. So an unlabeled bottle contains a straight chain halogenal alkane, okay. The molecular formula is this, and they say that it's a straight chain, so it means it has all the 5 carbons over there, and one of it is going to be X, which is going to be a halogen, bromine, chlorine, or iodine, yeah. We don't know what is that, okay, but normally they will do a test. So they say they add with sodium hydroxide and warm, and then they add dilute dilute nitric acid followed by aqueous silver nitrate. The moment you see dilute nitric acid, aqueous silver nitrate, okay, this is basically trying to find out what is X. Okay, what is X? So they found out that a cream precipitate is formed. Now, if it is a cream precipitate, okay, Catherine, can you tell us, okay, if it is cream precipitate, okay, what is going to be the identity of X? Is it bromine, chlorine, or iodine?
Bromine.
Yeah, good. Yeah, so if you look at it, okay, so Cl, AgCl precipitate, okay, is going to be white. Okay, AgBr is going to be cream, and then AgI is going to be yellow. So if you have cream precipitate over here, the identity of X is going to be bromine. Okay, so you write down bromine. And then write an ionic equation to describe the formation of cream precipitate. Quite simple. Okay, so it's Ag plus, okay, with Br minus to give you AgBr. Okay, you can just write solid, this is aqueous, done. Okay, describe a further test that will confirm the identity of X. This is where the aqueous ammonia, okay, will come in. Aqueous ammonia will come in where the expected result, okay, if you use here, okay, if you use dilute ammonia for AgCl, they dissolve. No need to use concentrated, but automatically they will dissolve. But for cream, the AgBr, dilute ammonia, they don't dissolve. Concentrated ammonia, they dissolve. Okay, for AgI, both also they don't dissolve. Okay, so in this case, you just need to mention, okay, expected result, okay, dissolve maybe little bit, okay, dissolve partially, or they don't dissolve, right? So dissolve partially, okay, using dilute ammonia, but dissolve completely using concentrated ammonia. That is going to be what you write. Yeah. The next question is the reaction of Q, okay, with NaOH tends to proceed with via Sn2 mechanism. So you see here, it's a halogenal alkane. Okay, halogenal alkane, and they are going to actually react with OH minus over here. So I just want to check with you guys. Yeah, Sharon. Okay, what type of mechanism is this? What kind of reaction? Is it free radical substitution? Is it electrophilic addition? So Sharon.
Nucleophilic substitution.
Yeah, even I think this one is the hint over there, as N stands for nucleophilic substitution. So here you see nucleophilic substitution is for halogenal alkane and another compound. Okay, can someone tell me what is the another compound, Jeffrey? Nucleophilic substitution applies for halogenal alkane and
Wait.
we'll ask someone else. Yeah, Audrey.
Is it alcohol, sir?
Yes, correct. Yeah. So alcohol and halogenal alkane will undergo, okay, nucleophilic substitution. Yeah, please remember that. So suggest the structural formula for the straight chain. You do remember here, Sn2 mechanism. We have Sn1 and Sn2. Sn1 is going to be for tertiary halogenal alkane. Okay. So Sn2 is for primary halogenal alkane. Tertiary means they can form carbocation. Okay, so primary, okay, they can only form the intermediate, yeah, the transition, the complex, yeah. So here, okay, you need to write down, okay, because they say suggest the structure formula. It means it undergo Sn2. It means it must be a primary halogenal alkane. So primary halogenal alkane. So if I put the Cl somewhere here, if I put the Br somewhere here, they are not going to be primary. It will be only primary if I put over here, because okay, there is going to be one entire R group over here. So if I want to write down the structural formula, okay, don't draw, yeah, this is structural formula. So you write down CH3, CH2, 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 Br. Okay, make sure you write accordingly. Okay, how to write? Yeah, you just need to use this one, CH3, CH2, 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 Br. Okay, you just need to put it back here. Yeah. The next thing is explain why the reaction tend to proceed with Sn2 mechanism rather than Sn1. Yeah. So here, this is a primary halogenal alkane. Primary halogenal alkane, they are only going to form a primary carbocation. Okay, so primary carbocation is not stable. Okay, it is only the tertiary is stable. But you need, since it's 2 marks, you need to mention more. Okay, you need to explain more. Okay, why this primary carbocation is not stable. So you need to tell, okay, there is only one R group, which is only one alkyl group that will exert the positive inductive effect. What is positive inductive effect? They are going to donate the electron. Yeah, so only one group exerting the positive inductive effect. Okay, so in order to be stable, okay, there should be more maximum inductive effect. Yeah, so in this case, okay, you do not have a stable carbocation. In order to get the full mark, you need to mention all this. Yeah, so that's why I put over there. Okay, primary carbocation not stable. Okay, and there is only one alkyl groups that will give you the inductive effect. Okay, therefore, they prefer to go through the intermediate rather than forming the carbocation. Okay, next. Okay, two different halogenal alkanes, okay, P and R, both with molecular formula of this, okay, are separately dissolved in ethanol, okay, and heated under reflux with sodium hydroxide. Yeah, so you see, they are dissolved with ethanol. Halogenal alkane, okay, dissolved in ethanol, heated under reflux with sodium hydroxide. So you see, the sodium hydroxide, if it is aqueous, they have one type of reaction. But now, if it is dissolved in ethanol, means in ethanol, okay, this reaction definitely going to give you elimination reaction. Okay, I hope you remember all this. Yeah, this is elimination reaction. Okay, so this is a different type of reaction, not the nucleophilic substitution reaction. Okay, it's an elimination reaction. So here, okay, the type of reaction is going to be elimination. And write an equation using molecular formula to represent the reaction occurring. Okay, so you see here what happens, C4H9Cl. Okay, so if I put it in a simple way, if you have something over there, let's say for example Cl and there is H. Okay, when I react, okay, with NaOH, okay, what happens? Okay, this one will be taken out, they will react and they will give you NaCl. This one will be taken out, will react with the OH, will give you H2O. So this one will give you C double bond C and so on. Okay, so similar to that, I need to come up, yeah, with the equation. Okay, so I just put, okay, plus NaOH. They will give me NaCl plus H2O. So C4 must be unsaturated hydrocarbon. So C4H CnH2n. Yeah. So this one is going to be the answer. Now draw the skeletal formula for methylpropine. Yeah. So in this case, methylpropine. Okay, propene. This is propene. Okay, methyl will come over here. This is CH3. So if I want to draw the skeletal formula of methylpropine, okay, 3 carbon, 1 carbon, 2 carbon, 3 carbon. So like this, and then double bond. Okay, and then there is CH3. Put like this. Then, okay, this is going to be methylpropine. Okay, why I don't put over here doesn't look good. Yeah, I don't want to put over here. Okay, now give the names, okay, of P and R. Okay, I need to give P and R, okay, the name. Okay, so the name over here, the major organic product of this reaction is methylpropine. Yeah, methylpropine. So it means that I am going to get something like this. Okay, something like this. So if I put, let's say, for example, this one, this is the major product, yeah. So C double bond C, CH3. So, but before that, okay, before that, we have removed hydrogen and Cl. Yeah, we have removed hydrogen and Cl. So maybe I'll just put the hydrogen and Cl back. Okay, so I just put here hydrogen here, Cl over here. Okay, and if I put, okay, if I put some more, okay, maybe the Cl can also come here. Okay, so if I put like this, okay, the H over here, Cl come here, something like this. Okay, there are two. Okay, so give the names. Okay, when I want to give the name, okay, so what do I do is going to be just need to name like normal. Yeah, so 1, 2, 3. Okay, so it's going to be propane. Okay, propane, and okay, propane. This one is going to be chloro and then methyl. Which one comes first? Okay, this is going to be carbon number 1. Okay, 1 chloro. Okay, 1 chloro, 2 methyl. Okay, or is it going to be we follow 2 methyl and then, yeah, I think definitely have to follow the 1 chloro first. Yeah, so 1 chloro, 2 methyl. So it's going to be written 1 chloro, 2 methyl propane. And this one, the straight chain is this. Okay, it's propane. Position 2, position 2. Yes, 2 chloro, 2 methyl. So if they, okay. So if you look at the question number 5, okay, the reaction sequence shows how ethene, okay, ethene, we know that, okay, the moment you see ethene, yeah, C2H4, okay, they have, okay, they are unsaturated, okay, so they will have double bond, carbon double bond, okay, and then 2 hydrogen over there. Okay, this ethene, okay, can be converted into other organic molecules. So you do need to remember, okay, whenever we are dealing with unsaturated hydrocarbons, okay, like alkene, okay, they will undergo this electrophilic, okay, electrophilic addition reaction. There are so many reactions, okay, that will come under here, electrophilic addition. If you're talking about saturated hydrocarbons, okay, alkane, then we are talking about free radical substitution reaction. Yeah, so this one is electrophilic addition. So if you look at here, okay, when you have carbon double bond and suddenly, okay, this is going to be a skeletal formula. So if you try to change it into normal way, yeah, I think I will always suggest you to change things into normal diagram, right? You see carbon and then connected to another carbon and then connected to OH. Okay, it means that the rest of it is going to be hydrogen. Okay, so here what we can see over here is going to be there is presence of OH. And if you want to see it more better, I think you just put the OH over there. Here you just put H. You can see it much more clearer. Okay, why we can see it much more clearer? Okay, because okay, the moment, okay, it's not appearing over there in my iPad. Okay, hold on, yeah. Okay, okay, now it's appearing. Okay, if I put the OH over there, okay, we can see that. Okay, we can see that the double bond. Okay, the double bond is going to be this double bond over here. They are going to be broken. One of it, okay, will have OH. Another one is going to be H. It means that, okay, there is going to be H and OH coming in. Yeah, H and OH coming in. So they are going to be added. Okay, they are going to be added to this particular substance. Okay, so when you have this, this is also going to be known as electrophilic addition reaction. Okay, but a special type of reaction, this one is going to be more addition of water. Okay, and we normally call it as hydration. Okay, hydration. So But normally when they say what is this reaction, normally we can just say it's going to be electrophilic addition. Just to be safe, if start with electrophilic addition, which is going to be addition of water or hydration. You can explain later. Yeah. So that is going to be the hydration. Okay, the first one. Now, once you have the alcohol, okay, do remember here you are going to have this this carbon, and then this is hydrogen. So you can see carbon. Okay, this is also carbon. So carbon, carbon, and then there is double bond O, and then there's hydrogen. So if you look over here, this is going to be aldehyde. Okay, so how do you get, okay, from alcohol, okay, to get aldehyde? Okay, this is going to be, if you just look at this structure of this alcohol, okay, the carbon attached to OH is attached to only one R group. Okay, this is going to be the R group. Okay, this is the R group. So therefore, it's a primary alcohol. Okay, primary alcohol, okay, they can be oxidized to become aldehyde, then they can be further oxidized to become carboxylic acid. So here, this is going to be aldehyde. It means it stopped halfway. Yeah, and to collect the aldehyde, there are some conditions. Yeah, they didn't ask, but you please take note. Okay, if you want to collect aldehyde, you cannot heat them under reflux. Okay, you need to heat them and then collect them. It means you heat them, okay, but you need to distill them immediately. Yeah, distill them immediately, because if you use the normal method, okay, just heat continuously, heat under reflux and so on, what will happen? Okay, everything will change into carboxylic acid. Yeah, so this one we need to be careful. And then the next, okay, do remember this is going to be changing alcohol, okay, to become carboxylic acid or aldehyde. This is going to be, if you want to write it down, this is going to be oxidation reaction. Okay, do remember, okay, this one I also noticed, yeah, in your textbook and even in the marking key, they only give one type of oxidizing agent. So let's actually focus on that, yeah, because I think normally I think potassium manganate, potassium dichromate, but in the textbook and the marking key, yeah, they are telling it's only potassium dichromate. So let's actually focus on that. Okay, we just take it as it's going to be potassium dichromate only. Okay, so Cr2O7, K2Cr2O7, acidified potassium dichromate. Okay, so this one is going to be used. Okay, now the next part is, okay, you can see a reaction 3. Suddenly you have, okay, the carbon, okay, and then another carbon. So you have carbon with carbon. This one is connected to this carbon, okay, and then triple bond N, and then OH. Okay, if you look over there, then it means this one, there is another hydrogen over there. So it means that this one is going to be something like the reaction of, if you look at this carbonate compound, okay, they can actually react, okay, they react with this KCN, okay, or react with ACN. So it means ACN, they will react with ACN, okay, with the KCN over there as a catalyst, okay. So generally, this is going to be the nitrile group will come and enter. Yeah. So that is going to be the product. Okay. The only reaction, okay, that aldehyde and ketone, okay, react. Okay, which is going to be, if they ask you what is going to be the mechanism of the reaction, okay, the mechanism of the reaction is going to be nucleophilic addition. Okay, nucleophilic addition, because all carbonyl compounds, they will undergo nucleophilic addition. Okay, so you can take note of this. Yeah. So the next part, okay, once you have this nitrile, we call it nitrile. Yeah. So there is OH, there is nitrile, and then they are going to heat with dilute acid. Do remember, when you have nitrile, okay, which is any kind of a C triple bond N, okay, this one, if I just put it as something like maybe I just put R, okay, if I put R, RCN, okay, I think it's a bit slow now, okay, RCN, okay, let me check the connection, hold on. If I put the RCN, okay, so I will actually, hold on. Okay. if you put this as RCN, okay, and there are two things that can happen, okay, RCN, nitriles. One, you react with HCl, okay, with the presence of water, okay, you can get carboxylic acid. How do you get carboxylic acid? So basically the R will still stay, and then C, okay, it will become double bond O and OH. Okay, and the remaining part, okay, you will have nitrogen, so they will have NH4, okay, and then the Cl. Okay, this is what you are going to get. Okay, so this one, okay, when you have this nitrile, you are going to get carboxylic acid. Now there is another reaction also, okay, which is going to be if you react with sodium in ethanol, then this is going to be a reduction reaction going to happen. Okay, a reduction reaction, okay, is going to happen where you are going to have, okay, the RCN, okay, you are going to have R, okay, it's not being reflected in the iPad, okay. Let's actually wait for a while. I think I need to restart every router and the connection, okay, because they just fixed it, okay. That's why there's a problem over here. Okay, let me share the content again. But do remember, yeah, when you have this nitrile, okay, they can have two reactions. Yeah? One is the first reaction to change into carboxylic acid. The second reaction is, okay, when you have this RCN, okay, RCN, okay, there were triple bonds over there. What happens is there is H, okay, reduction, okay, where they are going to have, okay, no need to put H plus, I think H only, okay, just put H. And then they, if I use the red pen here, one H will come here, okay, it's not appearing, okay, but once it appears, okay, you can see, okay, one H is coming down the C, yeah, now it's there. So another H will come here, okay, and another H will come here, one will be there, okay. So it means that, okay, if I erase the red part, okay, and then I straight away write the equation, it will look like this: R, C, H, H, N, H, and H. Okay, so this is going to be the amine, okay, still it's not there, but okay, once it appears, okay, you can actually see that this is going to be amine. Okay, amine is going to be produced as a product of reduction, okay, if you use sodium and ethanol, yeah. So that is going to be the product of reduction, yeah. So now coming back here, okay, so when you heat with dilute acid, so what you're expecting, you are expecting, okay, carboxylic acid, okay, you're expecting carboxylic acid. So this one is carboxylic acid. So the next part, maybe if we analyze here, if you have alcohol, okay, if you have alcohol and suddenly, okay, if you have this alcohol, suddenly this OH is going to be substituted by Cl, okay. This is going to be what we call nucleophilic substitution, okay. And today I taught you also nucleophilic substitution is going to be for two types of compound, okay, two types of groups, yeah. So what are those groups even? Nucleophilic substitution. Even so, for nucleophilic substitution, it can happen for two groups, yeah. So what are the two groups? One is halogenalkane, another one?
Alcohol.
Yeah. Okay, halogenalkane, another one is alcohol. Okay. So this halogenalkane and alcohol, okay, nucleophilic substitution, okay, you see that once, okay, in this case, you see the OH is going to be substituted by Cl. Okay, there are many reactions, okay, many regions that you can use, yeah. Like for example, you can use PCl5, you can use SOCl2, okay, you can use PCl3, okay, you can actually use I think that one is PBr3 and so on, PI3. Okay, so you can see all these examples that you can choose to get this done. Okay, so yeah, I think it's still disconnecting. Yeah, Given, are you still experiencing disconnection? Yeah, from me.
No, it's fine now.
Okay. I think I need to restart everything, because it's just got fixed. Okay, anyway, so you see here, the nucleophilic substitution can happen for halogenal alkane and alcohol. Okay, so now once you use that, so you have the halogenal alkane. Now you are going to change it with something with NH2. Now this one, this is going to happen. This is also going to be a nucleophilic substitution. You are substituting Cl, with NH2. How can that happen? This one you react, with ammonia. You react with ammonia, and this ammonia must be under ethanol. Means must be having the alcohol there. And then you will have this amine also. So do remember, this amine can be formed from halogenal alkane reacting with ammonia and ethanol. And just now also you see when you have RCN also, if you use sodium and ethanol, you can get amine. Roughly I just went through a lot of things over here. But now if we want to write down the if we want to complete this, you see, complete the table, to show the name of the reaction mechanism of reaction 1 and 6. So here, mechanism 1 and 6 only. So mechanism for 1. So even, what is the mechanism for 1? Alkene to become alcohol. Just now, I told you it's a hydration. So what kind of mechanism is that? Double bond. Something that has double bond, and then now you have hydration, the double bond is broken, and you have H and OH. So what type of a mechanism is that?
I don't know, sir.
This one. Already went through with you just now. So always remember, the mechanism, for alkene, mechanism for alkene is always going to be electrophilic addition, breaking of the bond. So this is going to be electrophilic addition. Electrophilic addition. Before I answer the name of regions and so on, let's look at 6. So let's look at reaction number 6. Now reaction number 6 just now, this Cl then change into NH2. What kind of mechanism is this? Halogenal alkane. What kind of mechanism?
Substitution.
Yeah, substitution. So to be exact, is nucleophilic substitution. Nucleophilic substitution. So you need to write nucleophilic substitution. And now, if we want to name the region and condition, so the region and condition, you need to also make sure, you use the correct region and condition. So you see here, hydration, you need to memorize. That's the important part over here. When you have hydration, hydration, is going to work, when you have, the reaction, you must use a catalyst. The catalyst that we use must be concentrated, concentrated phosphoric acid. Concentrated phosphoric acid. And you should know that we need to use 330 degrees Celsius. 330 degrees Celsius and 6 megapascal pressure. These are the conditions for this. So you can write down, which is going to be the name of the regions. You must use concentrated H3PO4. When they say name, so let's actually name it properly. Name, cannot write the formula. Concentrated phosphoric acid. 330 degrees Celsius, okay, with, okay, it means this is with water, right? So do remember, there is going to be hydration. It means with water, okay? H and OH is coming from water, okay? H and OH is coming from water, okay? That's therefore, okay, you must actually say this is going to be done, okay, with steam, okay? This is going to be done with steam, okay, which is the water, okay? 330 degrees Celsius, definitely water is going to be in steam form, yeah? And then the pressure is going to be 6 megapascal. Okay, done. Now, name, region, and condition for reaction number 2. This one. This is what I told you, okay? For your syllabus, I think they just want the oxidation of alcohol, just use the potassium dichromate, yeah? So when you give this, okay, you need to be very specific, yeah, because you need to name, yeah. So we just say acidify, okay, acidify potassium dichromate, okay, 6, okay, acidify potassium dichromate 6, okay, and then the condition, okay, the condition. Okay, rather than writing heat under reflux, I don't want heat under reflux, yeah, because it will change into carboxylic acid. I don't want that. Okay, so you warm. Okay, I think the best situation is you warm the okay, and then you distill immediately. So you don't write heated under reflux. Okay, distill immediately. Okay, or okay, you can say it's not in the marking key, but you can also say add drop by drop. Okay, I already taught you. Okay, add drop by drop, warm, distill immediately. Okay, that's going to be how you get the aldehyde. Now, nucleophilic substitution, number 6. Let's see, number 6. Okay, this is going to be the Cl. Okay, this one I already told you. Yeah, ammonia. Okay, and ethanol. Okay, so you are going to have, okay, ammonia, okay, in ethanol. Okay, the condition, okay, it must be heated, okay, heated in, this one is not written in the textbook, so you need to memorize, yeah, last time also I mentioned about this, heated in a sealed tube, or you can also mention heated under pressure. Okay, it means it must be high pressure. Okay, these are the conditions, okay, that we need to take note. Okay, so far, okay, even. Okay, let's move on. Okay, now in reaction 3, you see this reaction 3. Okay, the one that I mentioned about KCN and ACN. Yeah, please take note. Aldehyde, okay, is changing into the nitrile and the alcohol part. Yeah, so here, okay, they say that the in reaction 3. The organic molecule reacts with ACN, okay, and the KCN is the catalyst, okay, it's a catalyst over there. So complete the diagram, okay, to show the mechanism of the reaction occurring, yeah. So I need to complete this diagram. So what will happen, yeah? So you need to include the relevant dipoles, lone pair, curly arrows in your answer, yeah. So I'm going to show you, okay, what will happen. So first of all, okay, this is going to happen. Oxygen is going to be more electronegative than carbon. This is going to become delta negative. This is going to become delta positive. Carbon is going to become delta positive. That's the first thing we put. Second, okay, this is going to be, they already put this is negative. Okay, the reason this is already negative. So the negative one, this is the nucleophile. Yeah, the nucleophile is going to be attracted, okay, towards the carbon. Okay, it's attracted towards the carbon. So once it's attracted to the carbon, done. Okay, the CN is already being formed over there. So what happens, because the electron went to oxygen, you see this one, now this is negative. Yeah, what is going to be the next step? Okay, so now, okay, if you have this HCN, okay, when they come closer, okay, to this negative over here, what happens? The electron, they tend to go over here. The electron from hydrogen tend to go to carbon. Okay, so that is going to make this one delta negative. This is going to be delta positive. And what will happen? Okay, please remember the curly arrow shows the movement of electrons. So this is electron, so it will move over here. You need to show like that. Okay, so that is going to form, okay, the oxygen, or to be exact, if I erase this rather than showing from the negative, the oxygen, okay, is going to come over here. So what will happen? The OH, okay, is going to be formed. CN is there. So because the electron went over there, the carbon now become negative. A nuclear form is going to be formed. So you can see here, okay, you are already getting the products. Okay, so this is these are all the important informations that you need to put: the delta positive, delta negative, and so on. Yeah. So here they say that, okay, name the functional groups present in the product of reaction 3. Okay, product of reaction 3. This is the product which is the same as this. The thing, yeah. This is the product of reaction 3. So if you want to write the functional group, so even what will be the functional group in that product?
Alcohol.
Okay, good. One is alcohol. If you don't want to mention alcohol, what else you can actually mention other than alcohol? We can say hydroxyl group. Yeah, remember in the previous past year paper, yeah, hydroxyl group. Okay, so alcohol, okay, is correct. Alcohol, okay, that is alcohol. If you want to mention what type of alcohol is this? Primary, secondary, tertiary?
Secondary.
Yeah, secondary alcohol. If you want to mention, yeah, if you want to mention, it would be better. Yeah, secondary alcohol. Okay, but alcohol is okay, fine. Okay, N. What is CN? Nitrile group. Okay, remember this, nitrile. Okay, CN is called nitrile. Yeah, nitrile. Remember just now I was teaching you about this CN, which is nitrile. Okay, nitrile, they have two types of reaction. Okay, two types of reaction. So remember that. Now, these nitrile groups, okay, now you see, draw the structure of organic molecule W, okay, formed in reaction number 4. So you see in this reaction number 4, heated with dilute acid. So heated with dilute acid means they are going to look into this reaction. Okay, they are looking into this reaction. So it means now, okay, when heated with dilute acid, okay, so let's actually see what happened. Okay, so they want you to draw the structure. Okay, they didn't specify what kind of structure. If they didn't specify, okay, automatically follow what you have in the, okay, if they didn't specify what to do, okay, what kind of a structure to draw, follow the question itself. If you look at the question is telling about skeletal formula. So that is going to be a rough guide on what kind of structure you want to draw. So here you can see all in skeletal formula, you draw in skeletal formula. Okay, but now, okay, before I draw the skeletal formula, I just want to try the normal method. Yeah, you see here, H3C, CH, OH, and CN. Okay, so here, okay, I am going to react, okay, this, okay, with, okay, HCl, okay, dilute acid. Okay, they mentioned it's going to be dilute acid, and they didn't specify it's HCl. Okay, but I'm just going to put first HCl, then H2O. Must always put the H2O. So what will happen? Okay, you can actually see that, okay, a carboxylic acid will be formed. So this will stay. Okay, I'll use different pen here. CH3 will stay. Okay, and then the carbon, okay, this is the carbon. The H will stay. Okay, the OH will also stay. So I put the OH over there. So what is going to be changing? This one, carbon, okay, is going to change into double bond O and then OH. Okay, double bond O and OH. And then now, okay, you are going to have, okay, here plus, okay, the nitrogen, okay, will come here. Hydrogen, okay, NH4, okay, it's supposed to be NH4Cl, okay, so you will get this. So in the end, okay, if you put it over here, okay, I think if we try to balance this also, I think there is 4 hydrogen here. So I can see there is going to be 1 hydrogen here, okay, another 2 hydrogen over here, okay, so 4 hydrogen, let me see. Okay, there is going to be another 2, so I think I need to put 2 there. Yeah, so this is going to be 4 hydrogen. Okay, you will get this. Okay, so once you get this, okay, you are going to have, okay, this as the product. Okay, so you are going to represent this in form of skeletal formula. Okay, how to represent this in form of skeletal formula? Very easy. 3 carbon, 1, 2, 3. 3 carbon. No need to show. No need, already shown. No need to show the hydrogen here. The second carbon has OH. Second carbon has OH. I write down OH. Done. The third carbon has double bond O. Okay. So how do I put double bond O? Maybe I'll just put double bond O here. And then there is OH. So I just put OH here. Okay, that is what we want. Okay, so this one, okay, if you write like this also okay, this is the marking key, still correct. Okay, still correct. So how the marking key is correct? Okay, basically you can turn it around. Okay, flip it. Okay, I think it's still going to be the same answer. Okay, this is going to be the answer given in the marking key. Okay, so any question over here given? Okay, so this one, okay, is done. Okay, I will stop recording. Okay.